know that ultrasound is the go-to technology for greasing bearings right, but you also caution people on slow speed stuff.
Right. So, in order for us to use ultrasound to assist in lubricating bearings, we need to ensure that the bearing, the lubrication mechanism, leaves the churning phase, which is where where the lubrication system is volatile, where it's been disturbed, where it's been corrupted, if you will. And then when it starts to run better, when the grease has had a chance to get expelled from the raceway, we call that the bleeding phase, where the greasing mechanism now is supplying oil to the bearing. It's the oil that lubricates the bearing. It's not the thickener. One of the issues with slow speed bearings is that they tend never to leave the churning phase. So what does that mean to us? When a bearing is in the churning phase as part of the lubrication mechanism, it's considered to be high friction or higher friction. And then when it moves into the churning or into the bleeding phase a few seconds later, then the friction levels tend to drop down lower and sometimes substantially lower. When we're lubricating slow speed bearings, they tend never to leave the churning phase, so that there is no benefit to providing a minimal amount of lubrication added to the bearing. What I usually tell people is that you add more grease to a slow speed bearing because you're never going to find the optimal amount of grease. The more grease, probably the better in many applications. And when we do our training, we actually provide people with the information to determine exactly what would be considered slow speed for greasing, ultrasonic grease replenishment, what is slow speed, and what would be normal speed, where we would expect us to be able to notice a reduction in the friction levels when the bearing goes from the churning phase to the bleeding phase.